Welcome to Siding Institute. In our today's tutorial, we are going to revise on identities, basically on double angle identities. So we are going in this video. We are going actually to do question 9. Okay. So if you want all the solutions to all these questions, you can see on the screen even more of trigonometry. Don't forget to register under our tuitions. So this is my number, which you can just inbox me whenever you need help in mathematics, physics, and chemistry together with biology. So registration fee is just 70 kwacha per course. Okay, so let's get into our program so that we may have all these things simplified. Okay, so for you guys whom we started together in the holiday, we talked a lot of these things. So the first question is to prove sine x plus 90 degrees to be equal to cosine x. Very simple. So I was telling you guys that whenever we have two double angle identities under sine function, so the double angle identity which you have to know is this. So sine A plus B is equal to, we're going to have sine A cos B, cos B, and plus, because sine doesn't change this the sign, and you're going to have cos A cos A sine B. Okay, so this is the double angle identity for sine function when we are adding. Okay, this is the one which we just have to know. Okay, so what we do, as you can see now, from this we can see that sine A plus B, so our A is x and our B is 90. So you are going to write this in this form. So you are going to say sine x plus 90. We want to prove this to be equal to this. So now, using this double angle identity, this can also be written in this form. Okay, this is what the identity is telling us. So what we are going to say, we are going to say sine. Now where there is a, we are going to put x because x is just a. Sine x, then multiply by cos b, cos meaning cos 90, cos 90 degrees plus cos A. What is cos A, guys? Cos A is meaning cos x. We know we have cos x. Then sine B meaning sine 90. Once you are done with this, you are going to appreciate that what we've just remained is just the issue of special angles. Sine x will remain the same way it is. But I told you guys that cos x, cos 90 is 0. Okay, cos 90 is 0. You have to take note of that. So cos 90 degrees is 0. So we are multiplying by 0 here, plus cos x sine 90. All this you have to show when you are calculating. Sine 90 degrees is just 1. These are special angles, guys, for you who are new. So if you missed the lesson also on special angles, because the special angles and quadrants are very important in trigonometry. So special angles, so we have sine 90. So sine 90 is just 1, so we are multiplying by 1. 0 times sine x is 0. Cos x multiplied by 1 is cos x. So we have our answer 0 plus cos x, we have cos x. So you can even appreciate to say sine x plus 90 is just cos x, which is just the same as this. So I'm going even to say that the left hand side is equal to the right hand side. Hence, shown or proved. Okay, that's how you prove. Hence proved, just not double or just one or there, a single hole. So that's how you prove. So let's go look for the other trig identity. So b is cos y plus 90. So we have cos y plus 90 degrees is equal to negative sine x. So how can we prove that? We have the identity which you have to know. For the double identity for cosine, cos A plus B is equal to cos A cos B. Because we have positive, sine changes, cosine changes the sign. I explained all this. So we have sine A, sine B. So what do we get? We know that y here is going to represent A and B 90 degrees. So we just replace all the necessary things here. So our cos y plus 90, writing this just the same as writing cos A. Now A is going to be replaced by y. So it's y. Then cos B is cos 90 minus sine y. A is y. Okay, we know that A is y and B is 90. So sine y, then sine B, which is sine 90. What I was telling you guys, I was telling you that cos 90 is just 0 and sine 90 is 1. So what can we find here? We know that cos y times cos 90 is 0, so we're just getting 0 here. 0. Then sine 90 is 1, so minus sine y multiplied by 1. So what do we get, guys? 0 minus, so you are just getting 0 minus sine y, that is negative sine y. You can see that the left hand side, what do we have here? So there was a mistake in the way they asked the question here. We're supposed to have y here. Okay, we're supposed to have y here. It's either we change here or we change here. So it's supposed to have y. That's the only mistake which was made. So it's supposed to have y here, so that our left hand side now is going to be equal to our right hand side. So proving the identities is just very simple if you just understood all these functions, all these identities. So this is another identities for you who are watching for the first time. Okay, so I've got a lot of identities to talk about. So we've got this now, cos z minus pi, okay, is equal to negative cosine z. This is our C, question C. So as usual, when you have cosine, the identities cos A, now since it's minus, we say minus B is going to be equal to, cosine actually changes the sign. So since we have, and I said that cosine is more of selfish, so we are going to have cos A, cos B. Now we are going to have positive there. Then we are going to have sine A, sine B. In this case, our value of A is this and our value of B is this. Okay, so we just replace here. We're going to have our cos Z, okay, cos Z, then cos pi, cos B is pi, then plus sine A, which is sine Z, then sine B, which is sine pi. You know, guys, pi is just 1/8. When you convert pi to radians, what I was telling you guys, if you want to convert it to degrees, just multiply by 180 over pi, of which this and this are going to cancel. We're going to have 180 degrees. So what we are going to see here, just we can write this as cos z multiplied by cos. Here we replace by 180 because pi is just same as 180, then sine z, then sine 180. But what I want you to appreciate is that sine 180 is just 0. Okay, sine 180 or sine pi is just 0, so it's the only thing you have to know. Then what else do you need to appreciate here? What else do you need to appreciate? You are going to appreciate that the fact that our cos 180, okay, cos 180 or cos pi is equal to -1. I used to show you even using a graph why cos 180 is -1. So what you are going to have, we are going to have cos z, then cos 180. What is cos 180, guys? Is -1. So -1 plus sine z. What do you have about sine 180 is just 0. So that means, guys, we're going to have here negative cos z, and we can't add the 0 here because this is just 0. So you can see that even this is the one which we've produced. Okay, that's how you prove identities. As long as the right sides and the left side are one and the same, then it is proved or verified or shown. Those are the terms that you can use. Okay, so let's look about now question D. We've got about 5 or 6 questions, so I must be fast. So tan alpha minus theta is equal to tan alpha. So here is the double identity for the tangent function. So whenever you have a double identity for the tangent function, we have two good formulas. Number one, the first formula for a double identity, for when we are subtracting, we say tan a minus b. I'm also going to give for the positive one when we are adding, but here let's focus on negative. Since this question is for negative, there is a question which will require us to add. So we're going to have, when we are subtracting, meaning on top, that's how we used to remember. On top, we are going to say tan a minus tan b. Then down, that means we are going to add 1 plus tan a multiplied by tan b. Guys, these identities that I'm giving you, take note of these. So we know that the value of a is just alpha, and the value of b is pi. So we can replace now in the given equation. So we're going to set tan a, because tan a is alpha, so we're going to set tan, we need to see that this part should be equal to this. That's how we prove identities. So we set tan a, we set tan alpha minus tan pi. Pi is just same as 180, so it's tan pi, okay, over 1 plus tan a. We know a is alpha, tan alpha there, then b, we say tan pi. Okay, now what I want you to understand is that tan pi is just 0. Tan pi or tan 180 is just 0. So for you guys, those lessons you thought they were just very simple lessons on special angles are the some of the things that make students fail. So just take note of these concepts. Okay, take note of these concepts. So what you are going to see here, that whenever there is tan pi, we are just going to say 0. So we are going to, on top, we're going to have tan alpha minus, this is 0 according to this special angle. So for you who are hearing special angle for the first time, these are angles which we can just find without using a calculator. Okay, after you are just doing some some simple mathematical manipulations, we can able to find this, of which we talked about the special angle for the 60 degrees triangle, for a 30 degrees triangle, and for a 45 degrees triangle. Okay, so you can look for the lesson. For you guys who already registered, you have that lesson, so just go through if you have forgotten. And for you guys who are not yet, that is the reason for you to register. Just inbox me on this number. That is 666. I've shared the lesson in the first place, so that is minus 0. Then 1 plus tan alpha. Then tan pi is already 0. So what we have, guys, we have tan alpha minus 0 is just tan alpha. It is 1 plus, we can't add 1 plus 0. Okay, so what we have, we say tan alpha 1 plus 0 is just 1, so our answer is tan alpha. You can see that these and these are just one and the same. That's how we prove. We just show that the expression that has been given are true by make sure that the same way we used to prove for, guys, for you can remember on dimensional analysis in physics, we used to prove the equation if it is true by make sure that the dimensions on both the left and the right hand side are equal. This is just the same concept you are bringing here in mathematics. Okay, so what is E? Let's look about E. Okay, that's why I said the E as plus, our first as negative. So question E, what do we have? We have tan alpha plus pi over 4 to be equal to 1 minus tan alpha over 1 plus, we're supposed to have 1 minus also tan alpha. Okay, so as you can see, this identity is for when we are subtracting. Okay, as you can see in the question, we are subtracting. That's when we use this identity. But when we are adding the same identity, we are just going to change. On top we're going to have plus, you are going to have negative. Okay, so what we are going to have is tan A plus B is equal to tan A plus tan B, then on top 1 minus tan A tan B. Very simple. So in this case, our A is alpha and our B is pi over 4. So to make it simple, since pi over 4 can be difficult to most of you guys, you convert into it into degrees. So pi over 4, how do we convert into degrees? Say 180 over pi, so that pi can cancel, and 4 into 180 is just 45. Okay, so we are going to say tan A. What is A? It's alpha. What is B? Is pi over 4, which we've turned into 45. So tan 45 over 1 minus, what do we have here? Is tan A multiplied by tan 45. Tan 45. Okay, tan 45. So what else do we need to actually understand here? So what we need to understand is just simple. So what we tan alpha there still be tan alpha. So tan 45, for you remember special angles, guys, what is tan 45? Is just 1. So tan 45 we're going to have tan alpha plus 1 over 1 minus tan A, which is alpha. Did I identity replace here should have alpha, then multiplied by 1. So even if we multiply by 1, we still have tan alpha. So this is how our question is just going to be, guys. So as you can see the question, let me see the question. Yes, on top we have positive, not minus. So let me see. On top we have positive, then on down we have minus. Yes, so it's positive here. So that's how you prove. That's how you prove this identity. So you can just change, because this you can even start by 1. So it's you're going to have 1 plus tan alpha. Addition is commutative, so you don't change anything by changing that. So mine tan alpha. Very, very simple. So let's do the last question. Actually, no space for the last question. I got another question here. Okay, I'm going to do the last question. Yeah, the last question is, let me do the last question. Yeah. So this is the last question which we have. So we are going to do it here. No space. Okay, let's do it here. The question is tan. No, Abram changed the font. The font color. So we have tan. We have alpha minus pi over 4 is equal tan alpha minus 1 over tan alpha plus 1. Guys, since we have a negative here, this is going to be our A, this is going to be our B, but you are just going to use this, the one for minus. So I said tan A minus tan B. So what did we have? We have our A, which is alpha, and our B, which is pi over 4. But pi over 4, I said the same as 45 degrees. So let's replace here. You know, we had tan alpha. So what we just need to have is just to change here. We have 45 degrees, even here 45 degrees. It's the only change which you have to make. The rest are one and the same. So what we are going to have, we are going to have tan alpha on top. Then this is 1. I said tan 45 is just 1, so it's minus 1 over 1. Then since this is 1, so we're going to have 1 plus tan alpha. Very simple. These are very, very simple. So this is how we are going to have tan alpha minus 1. Then here we're going to start with tan alpha plus 1. So guys, let me give an emphasis. Trigonometry is not as easy as you can see the way I'm solving it. Okay, there are a lot of things that you have to know. Hence, if you are going to miss a lot of concepts, fail to answer any of the questions. There are a lot of videos that we discussed about trigonometry. We started by talking about what I talked about, conversion of degrees and lagrange. You've seen how important that part is from the question that we've covered. I talked about quadrants, very important, though in these questions we didn't talk about quadrants. We also talked about a negative angle identity. Then we went on to talk about special angles and identities. Identities are a lot. They are about more than, I can say, more than 10 identities. You just have to know. in terms of topics 10 parts of identity, but what if you have to paraphrase, because this identity which we've just talked about, we've seen identities about more than 8. Just one identity I'm talking about, double angle identity, but there are a lot of identities that you have to know. Okay, sum of two angle identities of double angle identities. In fact, this is sum of two angle identities. Double angle identities are those that are like sine 2x. You will find those identities. Okay, I talked about sine 2x, how it becomes sine 2x is uh, sine cos x, sine cos x, then cos x there. So I talked about all these things. So guys, if you need any help in chemistry, I'm repeating this, math, biology, and physics, just WhatsApp me on this number so that we make things simple for you. Semester 2, the topics are not, they are not many, but the concepts are very packed. It's very difficult to understand some concept, otherwise you need someone to explain for you. Okay, because in mathematics just have this trigonometry, we have matrices, we have complex numbers, we even start calculus. So just three, four topics. Physics of just a few, about 4 topics also. Chemistry, there are just about 5 topics. Biology, at least biology, there are main topics. So, but the concepts are very difficult to grasp, hence you need someone to explain for you. So if you are just interested in starting our tuition, just inbox me on this number and I'll get back to you as soon as possible. So thank you for watching, guys. See you in the next lesson. So I'm going to solve question 10 in the next lesson. If you be lucky, I'm even going to share for you guys who didn't register. It's a must. For those who register, they are going to receive these videos very fast as soon as I upload. Mind you, my videos on my channel, they are very few. That's why some people ask me why there are only 44 videos on your channel. But for those who have registered, they are able to access about more than 200 plus videos. Okay, for those who are in semester 1 can agree with me, we're together. And in semester 2, otherwise I haven't made a lot of videos, but I'm sure there are more than 60 videos now. I think 60 are not even now, more than 70 videos just for this semester. Yes, 70 plus. Because some topics like complex numbers, there are about 10 videos there. Trigonometry, there are more than videos I can't even count. So guys, thank you for watching, guys. See you in the next lesson.